This screencast is about Charles' law, Gay-Lussac'S law, and temperature conversions. In Charles' law, the variables are volume and temperature, and the constants are the amount of gas and the pressure. The relationship between the volume and the temperature of a gas is direct, and we see that in the graph here, which is a straight line that slopes up and to the right. This means that both variables increase or both variables decrease. The rules for Charles' law focus on volumes and temperatures. Volumes in Charles' law must be in the same unit. For example, both volumes must be in milliliters, or liters, or centimeters cubed, or meters cubed, or cubic centimeters. For temperature, all temperatures must be in Kelvin. To do this, you take a temperature in degrees Celsius and add 273. For example, room temperature of 22 degrees Celsius plus 273 gives us a temperature of 295 Kelvin. Let's take a look at a sample problem. Calculate the decrease in temperature when 2 liters at 20 degrees Celsius is compressed to 1 liter. Again, as with all gas laws, we are going to start by listing our variables. V1 equals 2.0 liters. T1 equals 20 degrees Celsius. And we want to add 273 to that so that we can have a temperature in Kelvin. 20 plus 273 is 293 Kelvin. V2 is 1 liter, and T2 is what we are looking for. Next, we plug our values into our equation for Charles' law. V1 divided by T1 equals V2 divided by T2. 2 liters divided by 293 Kelvin equals 1 liter divided by X. Next, we are going to cross multiply. So we end up with 2 liters times X equals 1 liter times 293. To get X by itself, we will need to divide both sides of the equation by 2 liters. Two liters cancels out on the left-hand side, so X is by itself. Now to solve in our calculator, we take 1 times 293 divided by 2, and we get 146.5. Our unit will be in Kelvin. Gay-Lussac'S law works the same way as Charles' law, except that now our variables are pressure and temperature, and our constants are the amount of gas and volume. Like Boyle's law, the pressures must be in the same units: atmospheres, kilopascals, millimeters of mercury, torr, or psi. It doesn't matter what the unit is, as long as both units are the same. Like Charles' law, the temperature must be in Kelvin. Let's try a sample problem together. A gas has a pressure of 0.370 atmospheres at 50 degrees Celsius. What is the pressure at 20 degrees Celsius? Again, we're going to start by listing our variables. P1 equals 0.370 atmospheres. T1 equals 50 degrees Celsius. Again, we have to add 273 to get a temperature in Kelvin. 50 plus 273 equals 323 Kelvin. P2 is our unknown. That's what we're looking for. T2 is 20 degrees Celsius. Again, plus 273 is going to give us 293 Kelvin. Now we plug our values into our equation for Gay-Lussac'S law. P1 divided by T1 equals P2 divided by T2. 0.370 atmospheres divided by 323 Kelvin equals X divided by 293 Kelvin. When we cross multiply, we get 0.370 atmospheres times 293 Kelvin equals X times 323 Kelvin. To get X by itself, we need to divide both sides of the equation by 323 Kelvin. This allows us to cancel out 323 on the side with X. X equals 0.370 times 293 divided by 323, or 0.335 atmospheres. Try these two practice problems on Charles' Law and Gay-Lussac'S law, respectively. Show all of your work and submit your answers with your notes either in paper to Mrs. Benke or on Schoology.